Good day, students. On this clip, we're going to be going over 4 examples on the art of adding, subtracting, multiplying, and dividing complex numbers. Okay, we are going to carry out the desired operation, and then we will graph the resulting solution and find the distance from the origin or the norm. Okay, so let's go ahead and write down the instructions for question number 1. So for number 1, we are going to, question number 1, find the sum of 6 minus 3i and 5 plus 4i. Graph the result and find the norm. Okay, the norm is just a fancy way of saying the distance from the origin. Okay, the norm and the distance from the origin are the same thing, distance from the origin. Okay, so we're doing 3 things here. We are finding the sum, and after computing the sum, we're going to graph the result, and then we'll find the norm or the distance from the origin. Alright, so let's go ahead and find what the sum is first. You know what sum means, right? Sum basically means you're adding. Alright, so we're going to add these two. So in this problem, so what I'm going to do is I'm going to carry out my addition operation vertically. Okay, so what does that mean? I'm going to line up my numbers up and down, stack them on top of each other. So I'm going to have 6 minus 3i, and I'm going to put 5 plus 4i on the bottom. You notice how I lined it up? I put the real numbers in the same column on top of each other, and then the imaginary numbers on top of each other. Okay, so this makes the addition easy and well organized. All right, so let's go ahead and add it. If I add the real part, I'm going to have 11, and then the imaginary part, minus 3 plus 4, is going to be positive 1i. Okay, so our sum, I'm going to call it z. Let's just call it z. Z equals 11 plus I. You don't need to put 1 there because 1 is a multiplicative identity. All right, so how do we graph this? If I want to graph this, I'm going to take this will be the real or the x part, 11, and then the coefficient of I will be the imaginary part, or the y, so that's going to be 1. Okay, if there's no number in front of I, the default number is 1. Okay, so this is what I'm going to be graphing. Alright, so our graph will just be a sketch. I'm not going to draw it to scale. It's just a sketch of what the point, where the point is. So let's make our coordinate system. So let's label it. This is my real axis. It's just like my x. And this is my imaginary. It's just like my y. Okay? Alright, so on the real is 11. This is the real. Well, I can just mark 11. Let me just go 2, 4, 6, 8, 10, 11. So call this 11. It doesn't really matter. This is just a sketch, and that's going to be 1. Okay? 11 and then 1. Alright, so now to graph the point is going to be right here. That is my point, and this is z. Okay? Now the other thing I was asked to find is, I was asked to find the norm, or the distance from the origin. I don't need to put that arrow there. Let me just put a z right here. Just call this z. I was asked to find the distance from the origin, or the norm, and that is basically this distance right here. How far is this point from the origin? This is the origin. How long is this? All right. So to find that, we're going to use the Pythagorean theorem to find this. This side right here is the distance from the origin. This piece right here, that is going to be absolute value of z, or norm z, that's the distance from the origin. Okay, so if I make this into a right triangle, you can see that this would be like my A right here, and then this side right here would be like this side would be a B, and this side right here will be a C. So what I'm going to do is I'm going to use the Pythagorean theorem, and then to find the distance from the origin, I'm going to say z squared is like my c squared equals a squared plus b squared. It doesn't matter which you call A or B. I can call this A and call that B. It doesn't matter. So I just go 11 squared plus 1 squared. Okay? This is from the Pythagorean Theorem. This is like c squared equals a squared plus b squared. Okay? Alright, so let's go ahead and work this out. Let me just write it on top so you don't get confused. I'm using c squared equals a squared plus b squared from the Pythagorean Theorem. Alright, so you're going to have z squared. 11 squared is 121. And 1 squared is just 1. If I add these two, I'll have z squared equals 122. To find z, to find the value of z, or the norm of z, I'll take the square root of both sides. Okay? So the absolute value of z, or the distance from the origin, is the square root of 122. Can I reduce this? Let's check and see. I'm going to check and see if I can break this down. Alright, so root 122. What goes in there? Take out 2. 2 goes into 122 61 times. This is a prime number, so nothing goes, so there goes my answer. Alright? So let's write down what this answer means. The answer means that the distance of 11 plus I from the origin is root 122. Okay, you're expected to include all of this in your solution. Okay, so geometrically speaking, absolute value of z right here, which is the distance from the origin, equals the square root of 122. Okay, and this z right here is your complex number 11 plus I. Alright, so there you have it. Okay, now let's go ahead and try another example. This will involve finding the difference. So for number 2, this is how we're going to consider the problem. So find a value of 7 minus 2i subtracted from 4 minus 5i. Graph the result and find the norm. Okay? Remember what the norm is again. The norm is the distance from the origin. Okay, so let's go ahead and do this. So first thing we're going to do is we want to subtract this from that. Okay, so when you're subtracting this from that, we're going to have to reverse the order. Alright, so this is being taken out of that, so we're going to write, it's basically, if I translate it into math, it's going to be 4 minus 5i minus 7 minus 2i. Okay, because we're subtracting this from that, so that's how you write it. Okay, I like to do my subtraction and addition in vertical form, so what I'm going to do is I'm going to stack these on top of each other. Okay, so I have 4 minus 5i minus parenthesis 7 minus 2i. Now anytime you're subtracting, you have to be extremely careful because signs do change. Alright, so you notice the parentheses I put here? I will have to distribute this minus to these two because subtracting is like adding the opposite. So I keep the top the same, 4 minus 5i, and I distribute the negative to these two numbers, so it's going to be negative 7 plus 2i. Okay, you see how this minus here got distributed to these two numbers, the first number and then the second number. It causes its signs to just change. Alright, so I'm going to add downwards. Add the real part and then the imaginary part. Alright, so adding the real part, 4 minus 7 is going to yield negative 3. And then minus 5, minus 5 plus 2 is going to give us negative 3i. Okay, so I want to name this result that we got. Let's call it z. Alright, z is a standard form for naming complex numbers in advanced math. So that's why I'm picking z. So let's call z negative 3 minus 3i. Okay, now if I want to graph this, I'm going to graph the point. I'm going to graph the point negative 3, comma, for the real part, this is like your x, and then negative 3 for your y. Alright? So since they're both negatives, that's going to be in quadrant 3. So let's go ahead and draw the graph. quadrant 3 because we're going to go to the left and then go down. All right. So this is, I'm not drawing this to scale, so it doesn't have to be perfect. It's just a sketch. All right, so let's graph it. -3. We're going to go 1, 2, 3. That's -3 on the real. And then 1, 2, 3. That's -3 on the imaginary. Okay, let's label our axis. This is the imaginary axis, IMG. And this is your real axis, RE. All right? Don't forget, this is the real part right here, and this is the imaginary part. The one that comes first is real and then imaginary. Your point Z is going to be right there, down. Okay? All right. Next thing we're asked to find is the norm, or the distance from 0. So from here to here, that will be the norm or the distance from 0. All right. And then if I want to write this down, the norm or the distance from 0 is basically this length right here, which is the absolute value of Z. Okay, Z is the point right here. This point is Z. Okay, so let's go ahead and find that. How do we find the norm? To find the norm, we're going to use what? The Pythagorean Theorem. We just talked about this. The norm is like C. This is like C. And then we have a triangle. This is like A. And then this side right here is like B. All right? So to do it, we're going to use the Pythagorean Theorem. These two are like A and B. So we're going to go Z square, which is like C square, is equal to A square, -3 square, plus B square, which is -3 square. Okay? Remember, Pythagorean theorem, C square equals A square plus B square. This is A, and this is B, and that's like C. Okay? So just put them all together, and this is what you get. Okay, let's solve this for Z. We're going to have Z square equals -3 square is 9. -3 square is 9. If I add both of them, I'll have Z square equals 18. Alright, so what is the norm? We just take the square root of both sides. So the norm of Z equals square root of 18. Now, can I break this down? Well, let's see. I'm going to break these down into its prime factors. Take out 2. 2 times 9. 3 times 3. Oh, wow, these two repeat, right? So they can break out as 3. This one doesn't repeat, so it stays behind, all right? So this becomes 3 on the outside because every pair comes out as 1, root 2, because 2 stays behind. So the norm of Z, or the distance from the origin, is 3 root 2, okay? So let's write this down in word form. What on earth does this mean? Well, it means that the distance of the complex number -3 minus 3i from the origin is 3 root 2. Okay, that's what this result that we just came up with means, all right? So let's put it here. The absolute value of Z, or the norm of Z, is basically 3 root 2. And then Z in and of itself is -3 minus 3i. Okay? So there goes your result. All right, let me box my answers so you don't get confused. This piece right here, this is the difference that we asked to do, and this piece right here, this is your graph. This whole thing right here, this is your graph. Okay. All right, and then the norm is basically the distance from the origin we're asked to find is this remark right here. All right, so there goes your main answers. If you want to box them, but you know, you understand how it works. All right, so there you have it. All right, now we're going to try 2 more examples, one on product and the next on quotient. So let's do the product one first, or multiplying. Number 3, here we're going to find the product of 3 minus 4i and 2 minus 3i. Graph the result. And find the norm. Okay? Graph the result and find the norm. All right. Remember, the norm is a fancy way of saying the distance from the origin. Okay, so graph it and then find the distance from the origin. All right, let's find the product. What is product? Product means you multiply. So we're going to be multiplying these two numbers. We're going to be multiplying 3 minus 4i by 2 minus 3i. Okay. So when we're multiplying, it's just like we're multiplying binomials. Remember in algebra 1 and 2, like x plus 3 times x plus 2. Remember how you multiply or you FOIL it out like this? This is exactly the same process that we're going to be using here, okay? We're just going to distribute terms across each other. All right, so let's do the 3 first. We're going to multiply 3 to these two numbers, okay? So let's do the 3 first. We're going to have 3, let me do it down here. 3 times 2 is 6. 3 times negative 3 is negative 9i. All right, that's first, outer. Now we're going to do inner, which is negative 8i. And then last is going to be minus times minus plus 4 times 3, 12. 12i, I times I is I squared. Okay, let's simplify this. We're going to have 6 minus and minus. You add them and keep the sign. So we have minus 17i plus 12i squared. Now what's wrong with this picture? Remember, I cannot have a power bigger than 1. If it has a power bigger than 1, it must be reduced, alright? So what is I squared? Remember, I is the square root of negative 1. Therefore, I squared equals negative 1. So anytime you have I squared, you have to simplify it and replace it with negative 1. Alright? So let's do that here. We're going to have 6 minus 17i plus 12 times, instead of I squared, I'm going to replace it with negative 1. Okay? Alright. Simplify further, we're going to have 6 minus 17i minus 12. Combining like terms, I'm going to combine 12 and 6. What is minus 12 plus 6? We subtract and keep the sign of the bigger one, right? So that's going to give me negative 6 minus 17i. And there goes my answer. Alright? So I'm going to call this final result I just got, this product, I'm going to call it Z. Calling everything Z, huh? So I'm going to call this Z. There's my result. Now to graph this, the same story. The A is the x coordinate, negative 6, and then the B is the y coordinate, negative 17. I'm not graphing this to scale, so I'm just going to make a sketch. They're both negatives, so we're going to be in quadrant 3. On the x-axis, we just go by 2's. So this will be negative 6. Let's just call this negative 6. And then this, let's just call this negative 17. This is not to scale. It's just a sketch, all right? This is my imaginary axis, the y, and this is my real axis, the x. And this is where the 2 points meet right here. And that point, we're going to call z, all right? So that's what z is right here. That's our first solution. Okay, so now that we have our first solution, which is the product, we need to, and we also have the graph, we need to find the norm. The norm is the distance from the origin, okay? So we're going to use the Pythagorean Theorem here again to find this. Remember, this is C, and this is A, and this is B, okay? So using the Pythagorean Theorem, C squared equals A squared plus B squared. We're going to try and find what Z is, okay? The magnitude of Z, sorry. So Z squared, which is the same as C squared, equals negative 6 squared plus negative 17 squared. Simplify that, we have Z squared equals 36 plus 289. And then Z squared, we'll combine both of them. That gives us 325. To find the norm of Z, or the distance from the origin, you just take the square root of both sides. Okay, so root this and root that. And then we're going to have the absolute value of Z equals the square root of 325. Now, can I reduce this? Is this reducible? I don't know. Let's try. So 325, what can I take out? Since it ends up in 5, let me change the color of this. Let me use, since this is not part, this is just a scratch work right here. So with 325, I can take out 5, right? Since it ends up in 5. Take out 5 from there. That gives me 65. Ends with 5. I can take out another 5. I'm left with 13. Now these two repeat so they can break out as a 5, okay? So the reduced form of 325 is 5 root 13, okay? So the absolute value of z is going to be 5 root 13, okay? So what on earth does this mean? This means that the distance of our product, the distance of negative 6 minus 17i from the origin, is 5 root 13. Okay? So that's basically how you do it. And this piece right here, that's your distance from the origin or not. Okay. Now, we're going to do one more problem. And then that'll be that. Let's go ahead and try out a problem involving quotients. Okay? So I'm just box a graph right there. There goes your graph. Okay. So now, a problem involving quotient is as follows. Question number 4. Question number 4, it says, express, or what is 4 over 3 plus 2i in a plus bi form? Okay? In a plus bi form. Graph the result. And find the norm. Okay, the norm is the distance from the origin. Find the norm. Okay, let's do this. So, starting from the original problem, 4 over 3 plus 2i. What's the problem here? The problem here is that you have an I in the denominator. That's not acceptable. The I can only be in the numerator. Alright? So to fix this problem, we have to multiply both sides by something called the complex conjugate. You get a complex conjugate by taking the opposite of just the imaginary side. Okay? So yeah, we just need to, you can have an I in the denominator, right? So the complex conjugate, you take the opposite of the I part. Alright, of the imaginary part. So this is what the complex conjugate is. I'll multiply top and bottom by 3 minus 2i and 3 minus 2i. How did I get this again? Take the opposite of just the imaginary part. What is the opposite of plus 2i? Negative 2i. And then you're going to have 3 minus 2i top and bottom. Alright? So multiplying across, we're going to have 4 times 3 minus 2i divided by 3 plus 2i times 3 minus 2i. So now we have a multiplication problem. Alright, so this is now a multiplication problem. So we just multiply. Distribute this 4 to these two numbers. So it's going to become 12 minus 8i on the numerator. And then on the bottom, we just distribute like we did on the previous problem. Alright, just distribute first, outer, inner, last, or you can FOIL it out. Okay? So let's go ahead and do that. So what I'm going to do is multiply the 3's first. So 3 times 3 is 9. 3 times negative 2 is negative 6i. Positive 2i times 3 is plus 6i. And then positive 2 times negative 2i is minus 4i squared. Remember, I times I is I squared. Okay? So let's simplify that. That becomes 12 minus 8i over 9. Notice these two are opposite, so they cancel out. Okay? So 9 minus 4. You cannot have I with a power bigger than 1. So I squared becomes negative 1. Okay? So simplifying further, we're going to have 12 minus 8i divided by, minus times minus is a plus, 9 plus 4. Final answer is going to be 12 minus 8i over 13. Okay? So we want to write it in a plus bi form, so that means we have to split up the fraction. So z is going to be 12 over 13. for the real part minus 8 over 13i for the imaginary part. All right. So to graph this point, to graph this number, we're going to have 12 over 13 on the real part, and then negative 8 over 13 on the imaginary part. All right. So we're going to go to the right and then down. So that's quadrant number 4. So let's make our coordinate system. Remember, this is just a sketch. It doesn't have to be perfect. So we're going to go make a mark on the real axis. We're going to call that 12 over 13. And then let's go down here. This is going to be negative 8 over 13. That goes on your imaginary axis. Remember, the imaginary is like y and your real is like x, okay? The points meet right here. So that point right there, which is the graph of this, is z. Okay? Alright, so now, what do we have to find next? Let me box my answers so I don't get confused. I already found z, which is the quotient. Now, and this is my graph right here. I have to find the norm, which is this piece right here. Okay, so how do we find that? That is the norm. Okay, so to do this, we're going to use the Pythagorean theorem like we did before. This is the magnitude of z. So for this one, we're going to go z squared equals 12 over 13 squared. That's a squared. Plus b squared, which is negative 8 over 13 squared. Okay, remember this is like c, and this is a, and that's b. Alright, so we have z squared equals 144 over 169 plus negative squared, the negative goes away, 64 over 169. Alright, now if we work this out, we're going to have z squared equals add this up, 208 over 169. To get z by itself, you take the square root of both, square root of this, square root of that, and then the square root of the denominator. Alright? So the norm for the distance from the origin, the absolute value of z is going to be the square root of 208 divided by the square root of 16. We know that that's 13. Okay? Alright, so can I simplify roots 208? Let's see. So let's do that on the side. Roots 208. Let me do it on the left side this time. Roots 208. Since it's even, I can take out a 2. If I take out 2 out of 208, I'm left with 104. Take out another 2, and I'm left with 52. Take out another 2, and I'm left with 26. Take out another 2, and I'm left with 13. 13 is prime, and nothing comes out of there, alright? So in order to break out of the square root, you need the number to repeat itself. So these 2 repeat themselves, so they can break out as 2. These 2 2's repeat themselves, so they can break out as 2. So this is going to be, oh yeah, 13 stays behind, okay, because it's alone. So this becomes 2 times 2 root 13. Okay? What is 2 times 2 root 13? 2 times 2 root 13 is, you just multiply these two 2's together, so it's 4 root 13. Okay? So this whole thing, norm of z is 4, the product of these two 2's that came out, root 13, which is this 13 that never broke out because it was by itself, over 13. Alright? So what does this answer we just arrived at mean? It basically means that the distance of the complex number we got, which is 12 over 13 minus 8 over 13i from 0, or from the origin, which is 0, 0, from the origin is 4 rad 13 over 13. Okay? So that's basically the distance from the origin using the Pythagorean theorem on the complex number that we arrived at. Okay? So we can include the significance of this on the graph also. Norm z up there is 4 root 13 over 13. So this one is basically, I can put it down here, 4 root 13 divided by 13. And then z, my complex number, is 12 over 13 minus 8 over 13i. Okay? So there you have it. Alright, so thanks so much for paying attention to this presentation. Please feel free to subscribe to my videos. Just click up here to subscribe for future updates and share with your friends on Google+, Facebook, or Twitter. You can also request my videos in the comment section. I'll be glad to try and help you out with your questions. Like this video down here if you liked it. If you didn't like it, don't give me a thumbs down, please. Just put a comment saying what you didn't like, and I'll try and address it in this and future videos. Okay, so thanks again and have a wonderful day.